Here we have a typical neighborhood with a buried underground transmission and distribution system for the electrical power. The only evidence of that is the fact that there's no wires above ground around here, and we have a transformer sitting above ground, and this takes the higher voltage 7200, let's say, volt distribution line voltage and transforms it to 120 and 240 volts that is fed to the houses. This is a perfectly fine system, except in a situation where we have a distribution line issue where we have unequal current flow, delivery and return wires that are buried in the ground. And when we have that situation, we have a net current, we have incomplete cancellation between the magnetic fields around the wires that we talked about earlier. And then we have a very large magnetic field that surrounds the wires, and it reaches out so far that it actually affects the homes along this buried distribution line. We've even seen cases where the buried distribution line has actually gone between the houses to another street, and therefore we have the field that is affecting both houses on either side of the line. We didn't have an issue in this neighborhood, but we did find an issue in another neighborhood, and we'll transition to that now and take a look at how it affects the houses that we were evaluating at that time. So we've moved to a neighborhood now that has above ground power distribution system. This neighborhood, you can see behind me, and there's a pole off to my left, and at the top of that pole there's a transformer. That transformer is taking the higher voltage, let's say 7200 volts, that's being distributed at the top of those poles, and it's reducing it down to 120, 240 for delivery to the house. We get a lot of questions from clients about these transformers. Are they dangerous? Do I have to worry that there's one near my house? And the answer to that is that these are known as point sources, and point sources have a characteristic where the field decreases very rapidly, actually at the cube of the distance. So for example, if we were 10 feet away from this transformer, the field level would be 1,000 times less than it is right next to the transformer, approximately. So in this case, distance is your protection, and in most cases these transformers are not so near to your house that it's a problem. I can think of one situation where that might not be the case, and that would be in a community which had alleys, and they ran the power lines down the alleys, and the houses were built out nearly to the edge of the alley, and sometimes you'll find a transformer hanging almost right outside the bedroom window. Then these become an issue and something that you may want to draw to your client's attention. So we have a condition in elevated or above ground distribution systems that we talked about when we were looking at the below ground distribution system or the buried distribution system. And that's where there can be an unequal current flow on the supply wire versus the return wire. That's a condition caused by the power company. We won't get into why it happens. It doesn't have to happen, but it does sometimes. When that happens, there is this large field around the wires, and it'll affect the houses along the street. We don't have that situation in this neighborhood we measured before we started taping, but it can happen, and we've seen it plenty of times. Often, as a matter of fact, it can affect the houses along this street and the houses over along the next street, because the problem that we have is affecting the distribution lines that are going along both streets. So when you're measuring outside the house and you see high magnetic field levels, they're not coming from the house, they're coming from something outside the house. It would be typically this type of situation: buried distribution with unequal current flow, or overhead distribution with unequal current flow. Not accepting the fact that if you're really near a transformer, you could have an effect from the transformer inside the house. So in this particular case here, if we had discovered this unequal current flow and the high magnetic fields, and they were being measured inside the house, in most cases this is a deal breaker. We have found people who are able to work with the power company over a long term. It's not an instantaneous sort of fix, where they come in and they address the issue that's causing this looped distribution current, as we call it. And when they fix that, things are okay. We're going to go to a neighborhood with a transmission line. So we've left the neighborhood with the overhead distribution line, and we've come to a neighborhood that has a overhead transmission line, and I emphasize the word transmission. Transmission lines run at very high voltages, 100,000 to 300,000 volts, and they're used to move large blocks of power between communities. And here on this street, we have a transmission line which runs across the street. And the level of fields at this location, which is about the distance the houses across the street are from this transmission line, we're running a 7 milligauss magnetic field, which would be what would exist inside the house. From our perspective, we want to see fields that are no more than 1 milligauss. We certainly want to see fields that are, if we can, that are 0.2 of a milligauss or less. And studies that were done in Europe probably 15, 20 years ago now, in Sweden, show that magnetic fields in excess of 1 milligauss double the cancer risk in children. Over 2 milligauss, they triple it, and over 3 milligauss, they quadruple it, and we're looking right now at 8 milligauss. These field levels go up and down based on electrical demand across the region. So when we're air conditioning in the summer, these are going to rise. When people come home, start turning on the lights, turning up the heat, or turning on the air conditioning in the summer, these numbers go up. So, you know, from our standpoint, the readings in this neighborhood, all along this line, up and down the entire block, which is quite long, are way, way in excess of the acceptable level. They're 8 times, 800% over that.